The first thing to note under binomial is how to do this expansion. This is the most important thing there. Okay, this formula is very important. Okay. So this is a very, very important formula because it sorts out so many issues to do with series and application. Should they ask you for the range of validity, your main focus is you do that. That's our focus. Okay, from that, you also need to understand how to get the term. It's always this formula. This one gives us a range of validity. Okay, so that's the TR plus 1. That's a term. If there's any question that involves the term, that's what you use. And that's what we expect. We don't expect much things to be asked in this exam from binomial. We just expect to use that formula and use the one down. The other expansion should be quite easy to do. So let's pick some questions from here. I will start with change focus. We'll start with question 16. So we'll combine it. So expand 1 plus x to the power minus 7 up to x power 3 and approximate 1.01 power minus 7. So if we go back to our formula, when you pick 1 plus x power minus 7, I'll start expanding. You just substitute there. Where there's n, there'll be minus 7. And then minus 7 and minus 7 minus 1. We're dividing by 2, x squared. And then minus 7 and minus 7 minus 1 and minus 7 minus 2. And we are dividing by 3 factorial, which is 3 times 2. And then x plus 3. So that's how we do the expansion. So now what means is first, just get back a bit and simplify. So 1 minus 7x. This is the minus 8. We can divide the 2 there. So we'll get minus 7 times 4. That's going to be plus 28 x squared. And this will be minus 8 again. This is minus 9. So 3 here, 1, 3 there, 3. 2 here, 1, 2 there, 4. So we're having another number. That is 7 times 4 or times 3. So we get minus 84 x power 3. That's our expansion. We now want to use it to approximate 1.01 to the power minus 7. So we get 1 plus x and we get it 1.01. So that x then becomes 1.01 minus 1, which is equal to 0.01. Okay, so this means that 1 plus 0.01 to the power minus 7 is now going to be 1 minus 7 times 0.01 plus 28 times 0.01 power 2 minus 84 times 0.01 power 3. Also, the tedious job of putting these numbers together, I think with the mind that is in the exam, it should not be that difficult. I believe you can do that multiplication and quickly get to sum, subtract, and have the solution. But you may not expect to have big numbers like 7. Maybe they can just quickly get 1 there for easy calculation. If they ask us to say, find the range of variability, let's go back there and say, that's the value of x. You understand? 1. So of interest is the question that was asked in the test. So let me look for that test paper. Now we have to find it should be on the test. That should be test 2. No, test 2. So after you do the expansion, so after you expand, you now want to approximate. So since what you're expanding, what you were expanding here was sitting under power -7, and you want to approximate the thing that is inside. So still sitting under the power -7. So just equate what is inside. 1.01 to 1 plus x for us to be able to have an easy calculation. That's why we have to do that. And later on, just substitute what is x. Okay, I think I found the question I'm looking for. Find the coefficient of x power 3. Okay, so this was question 1. It was question 3a. Find the coefficient of x power 3. In the expansion of 1 minus 2x to the power 7, 3 plus x to the power 2. So if you expand this, your interest is the term that has x to the power 3. So what we do is we'll expand those two up to x power 3. So the first one, so we have 1 minus 2x power 7, and then 3 plus x power 2. So we'll have, from the first one, we'll have 1 plus 7 times minus 2 plus 7, 7 minus 1 over 2 times minus 2x squared plus 7, 7 minus 1 7 minus 2 over 3 times 2 minus 2x plus 3. So we have this multiplied by, we also expanded this. Now that is power 2, we just expand it fully. So we have 9 plus 6x plus x squared. I'm sure we all know how to multiply 3 plus x times 3 plus x. Okay, so after that, the question is demanding for the term in x power 3. So we're going to correct only those terms in x power 3 after we've expanded. So this one will not help us get any term in x power 3 because when you multiply 1 times 9, you get 9, you get 6x, you get x squared. None of them is in x power 3. So we got the next one. This is minus 14x. If we multiply it by x squared, we're going to have x power 3 there. So we keep it and then come here, pick this, that's plus 7, 6 over 2, 4x squared. So this we multiply by 6x. Again, we have x power 3 there. Okay, when we move, we take this one, plus 7, 6, 5, and then 3 by 2, and then minus 8, x power 3, and multiply it by 9. Okay, so if you multiply by anything else, the power won't be 3. So we have put together the things that have x power 3. So our job is just to do the addition. So this is minus 14 x power 3. This is 3 here. So we're going to have 1 times 4. 1 times 4 times 6. That's 504 x power 3. And then this and that cancels. Again, we get 7 by 5 by 8 by 9. And it's minus. So we have 2520 x power 3. So we can now put this together. So minus 14 plus 504. So this is going to be 3010 x power 3. Why are we using this formula when the power is greater than 0? This formula is used for any power. The power doesn't have to be negative or a fraction. It can be 2, it can be 3. The power can be anything. For as long as we have 1 plus or 1 minus something, we can use that formula. Yeah. Then there's another question. Like somebody asked in the group, let me try to follow up that question without being in the
I have a question.
Yes. What's your question?
Why is it that we're not multiplying 3x plus 2 plus 2 squared the same way we multiplied 1 minus 2x, as in using this formula? Why are we using different formulas?
Why aren't you expanding 3 plus x power 2 using the formula?
Yes.
So 3 plus x power 2 is this. So it's easily done. You don't need the formula this one.
Oh, all right. Thank you.
So
Hello.
I didn't see how you used that 9 plus x plus x squared in the expression.
So we were picking like the x squared, we picked it here first. Because our interest is to collect all the terms that will have x power 3 after an expanded. So when we use 1, we are multiplying this thing by this thing. So if you use 1 and multiply by 9 by 6 by x squared, none of the terms will have x power 3. But if we use this one, which has x, multiplied by 9 or by 6x, again, none of them will have x power 3. But if you multiply this, which has x times x squared, then we realize a term that has x power 3. So we used it here. We got the next again, multiply this by 6x. Since this is power 2, when you bring in power 1, we're going to have power 3. The next thing, when you get power 3 already, you can't go to where it's x because you jump to power 4. So you go to where there's a constant line so that you maintain the power. And then you do the collection of both and add them.
All right, so
Yes.
Yes, so if you are getting the validity of this 1 minus 2x, so meaning that the answer is going to be x in the modulus less than half.
Yes.
Sorry?
Yes. Okay, then there was a question asked in the group. If the term independent of x are in the expansion of x minus y over x power 6 is 68. Find the value of y. If when you expand, you discover, this is telling us that, well, if you were to look for the term independent of x in your expansion, that term is going to be 68. But looking at what you have, you may not see the 68. It will be hidden in some y or something. So find the value of such a y. If you discover that it's the only thing you have which doesn't have x, what do you do for y to make it 68? So ours is to find the term independent of x. Okay, and things will sort out themselves. Okay, so we'll have a n minus r br. That is 6r, and then x 6 minus r. So 6 minus r, and then the b part, you write it as minus y power r and x power minus r. That's how we write the impact. So now we have 6 r and then minus y r and x 6 minus 2r. So we put the powers of x before. And then now we want the term independent of x. So we say x minus 2r is equal to 0. So that minus 2r is equal to minus 6. And so r is equal to 3. So we go back and say the term we are looking for is actually 3 plus 1, 10, which is 6, 3, and then minus y power 3. And because the x is now, we need to substitute there, it will to the power 0. So now we need to calculate what 6 plus 3 is. This is 6 factorial over 3 factorial, 3 factorial. Okay, which is 6 by 5 by 4 by 3 factorial over 3 factorial by 3 by 2. So this cancels. And then 3 and 2 take away 6. So we get a 20 from there. So we have a 20 minus y power 3 equal to 68. Because we are told when you have found that term, be sure it's equal to 68. So now solve the equation. So for y. So for y we divide. So we have y3 is equal to 68. And we divide by minus 20. That is the 4 there over 10 minus. Again, and that is minus 17 over 5. So it means that y is equal to cube root. So cube root of minus 17 over 5. So it's just to know that the term I should find independent of x should be equal to 68. So if the term is equal to 68, then after I find it, I equate it to 68 and find the y. Because now it is manipulated.
I have a question.
Okay.
Why is the negative 20 coming from? Y cubed is 68 divided by negative 20.
Where is the
What's
negative 20 coming from? So here we are calculating that value. Well, maybe 5 times 4, which is 20. So that 20 is only equivalent. Give this 20. The negative is coming from the net negative part.
All right, thank you.
So I'm asked to go back to question 3. And so the question said the coefficient of x power 3. They must find the coefficient of x power 3 in that function. So if I'm told to find only the coefficient of x power 3, I'll have to expand this part, expand that part, then combine. After I've combined the term that will have x power 3, I'm interested in its coefficient. So now we have this 1 minus 2x power 7, 3 plus x power 3. So we multiply, we expand up power 3. We also expand this one fully because the power is too small. It'll be left hanging. So we expand it through. Then now do the combination. Do the combination. So multiply this term by that term, but because you're looking for x power 3, there's no need of multiplying everything by that term. I only multiply those whose powers when I combine will be power 3. There is x here, comes x squared. I get x power 3. There is x squared here, comes x. I get x power 3. There is x3, comes 9. I'll get x power 3. And what remains now is for me to put these together. And then I'll know the coefficient of x power 3 is 3010. After we found R, we substituted it in the formula. And we had this. So from here now, we need to know what 6 plus R is. So 6 plus R is located here. That's come out to be 20. So we come and substitute here. What is 6 plus R? I put here 20. But negative y power 3 is still negative y power 3 times 20 now. The whole thing must be equated to 68 because we are told the term that won't have x is equal to 68. This is an equation. You need to know what y is. So you solve for y and z. That's why we are here. So the binomial is just about the formula. The formula for the term, the formula for the expansion. They'll ask you about coefficient. Coefficients, mostly, will give you a power they're interested in. So yours is to find a term with that power. You then be able to plot out the coefficient of that thing. It should be that nice. So we really don't have to stress on time. It's just a term expands, approximates, term. Simplify, so it's not difficult. Most things you have talked about them here. If you could just be honest enough and help us on Monday by getting correct whatever we have talked about, then we'll clear the exam. Where we'll find the difficult as a group is where, even what we have agreed today, that is, if they ask you to find a term, this is what you do. If they ask you to expand, this is what you do. Then you don't expand. It's difficult for us. So we can use the binomial formula. Look, the issue is, I just don't want to complicate my life by starting memorizing the formula just for power 2. But if the power is bigger than 2, I can use the formula. As long as I know. Okay. Then, in the deferred test, this is what we ask you on the term. We say, find the coefficient That question can only be found in the information. So in the deferred, they were given this question. Over. Power 2. And it's to ask for the same. Okay, it's to ask for the same. So if you are given that, you just move a step. Okay, power 7, and then power minus 2. At this point, you use the formula now for both. So you have 1 plus 7 minus 2 minus 2x plus 7 6 over 2 minus 2x squared plus 7 6 5 3 by 2 minus 2x power 3. This multiplied by, we now come here. The power is minus 2. So we first want to make our way easy. We factor out a 3 and have it in this form. Power minus 2. Even here, power minus 2. So let me write it down here. So it will be 3, then 1 plus x over 3, power minus 2, power minus 2. Which you can write as 1 over 9, and then 1 plus x over 3, power minus 2. You can do the expansion here. So that 1 over 9 is written here. And then you have 1 plus minus 2x over 3. And then plus minus 2 minus 3 over 2. And then x over 3 power 2 plus minus 2 minus 3 minus 4 over 3 by 2 x over 3 power 3. Then you do the same combinations for you to get the power that's needed. So I'll leave it for you guys to do the combination. But if they ask you to find the range of validity, you would pick minus 2x less than 1 intersection x less than 3. You get the intersection of the two intervals. This interval here is minus half less than x less than half. Intersection minus 3 less than x less than 3. So you know that it's minus half less than x less than half. So we get back after 10 minutes. We come and talk about trigonometry.